All right, welcome to the stream, everybody. My name is Nick Larson. Happy Wednesday? Yeah, happy Wednesday. Today is July 3rd, 2019. It's about 12:05 in the afternoon. A few minutes late because I had a little false start on getting this thing going. And today is a good day. This morning we had a test for something that I've been working on for about 6 weeks. We call it a crash test, which is basically like we're testing the technical bits, but we know we still have a little bit of work to do before we can actually launch a full experiment. The technical bits went off without a hitch. We got through everything. There were no exceptions being thrown. The site stayed online. Everything was good to go. The only thing we have to do is figure out the issues with the model and get that all swapped out, and then we'll get things taken care of. So that was a good start to the day. And now, today I would like to get into a little bit about a question that I get asked a lot, which is, how do you prepare for an interview? This talk is mostly going to be geared toward like people who either haven't had an interview in a while but are still kind of early in their career, people who are like looking to get their first job, people who are looking to, what would you say, people who are like graduating from a boot camp, stuff like that. All right, that's sort of the angle that we're taking here. Um, and I kind of just want to go through it because it's something that you can learn, and it's actually a pretty simple thing once you get into it. And the methodology that I choose really sort of highlights the things that the companies who are interviewing you are looking for. And I want to just sort of lay out the groundwork, help you get started with it, and then we'll get into actually solving some problems, and you'll see how we can go from not solving any problem in a reasonable amount of time to solving a large number of problems in a reasonable amount of time. So first off, let's switch over to full screen mode. We're going to take some notes here. Uh, Probably, yep. All right, we're going to take some notes here. The notes work sort of like this. First thing that I want to go over, and we're just going to take them in like markdown mode so that we can make a blog post out of this when we're all said and done. The first thing we want to go over here is how to prepare for an interview. All right, and the first thing I want to talk about is understanding the key skills. All right, the key skills that are being looked for in an interview really come down to three things. The first thing is your problem-solving skills. The second one is your coding skills. The third one is your debugging skills. If you don't believe that there is a difference between these three things, hopefully I can convince you otherwise. And it works sort of like this. Your problem-solving skills have nothing to do with coding. Literally nothing to do with coding. Your problem-solving skills have to do with being given the requirements of a problem and then formulating a solution. And that's it, right? It doesn't matter how that solution gets implemented. It's very conceptual. And we'll take a look at this via an example, right? So I was looking and doing some mentorship earlier this week, and there was a problem that came up, which is, let me just pull it up here, Leet Code. Hey, the Hugo Doll, thank you so much for the subscription, man. I really, really, really appreciate that. 2 months. I think you're my first 2 month subscriber. Thank you so much. Even my wife's only at 1 month. I'm doing great. I'm taking this Wednesday. We're gonna do a little bit of mentorship planning, which is that a lot of people have been coming to me and asking me all about how to get ready for interviews, and we're coming up on interview season right now. Lots of people just graduated from school, just took the summer off, getting ready to get their first job. A lot of people are getting ready to graduate in December, and the beginning of August is a very common time for boot camps to like end their, God, what do they call them? Not quotas, partitions, cohorts. All right, LeetCode.com, and I'm just currently looking up, this is it right here. All right, so this is, and let's open this in a new incognito window. All right, this is the problem that I was looking at first of all. And it works like this, right? Which is, given a string which contains a Roman numeral, how do you convert it to an integer? It is always useful, man. I get asked this all the time. I get asked this literally every single time I work with boot camp students about, you know, one of the things about boot camps is their entire business model is based on like how likely you are to get a hopefully this will help you out, right? So like the plan here is we're going to talk about first about understanding the key skills of an interview, but really this comes down to like, just being good at your job. So hopefully there is going to be something for everybody to learn here. If nothing else, in really like breaking down and understanding how to highlight these particular skills when you're talking about the stuff that you do. Or, when you end up interviewing someone else because you need to, do the hiring at your own company. And being able to focus in and drill down and make sure that you're identifying each of these things in your interview, as opposed to just saying, oh yeah, it was a good interview or a bad interview. Instead, you really want to actually look for these things and scale these things. Yeah, that's it. So let's start by example, which is, all right, the first one. Given a string which represents with a Roman numeral in it, we want to convert it to an integer value, right? The problem-solving skills, the problem-solving part of this is solve this as a human. And I want to drive this in really, really, really hard, which is solve this as a human, okay? And this means don't worry about the code. Don't worry about the optimal way for a computer to do it. This is about, can you go from not having a solution to this problem to having a solution to this problem? And that's it. That's the entire skill, right? Whether you come up with the most optimal solution or whatever, that's where you land on the scale, but you're always at the bottom of the scale if you cannot come up with a solution, period. So always come up with the most naive solution possible. And to do this, I recommend doing it using your fingers. I can't reach my hand all the way up there, but basically on the screen, you would put your finger where you want to track things and sort of walk through your solution, right? So when I see something like this, I'm like, okay, I know that these symbols are the values of each of these letters. However, I also happen to know that, and the explanation tells me, that in some cases you can have two characters next to each other that alter the value, right? So what we want to do is we want to make a full list of all the symbols. Notice I haven't said how to do that. Notice I haven't, specifically written out any code. All I want to do is identify all of the unique symbols, and I would probably go ahead and do that by hand, right? Because there's just not that many of them in this case. So and in fact, they're all listed out here. So if we put an I before a V, we get 5, so we need to add IV to this list. We need to add IX to this list because putting an I before an X gives you 9. We also need to add an XL and we need to add an XC to this list because that gives you 40 and 90. We need to add a CD and we need to add a CM to this list because that gives you 400 and 900. And that is literally all the Roman numerals, right? So we now have a lookup table that has the symbols. They may be one character, they may be two characters, and then the value that symbol is worth, right? Now what we're going to do is we're going to start at the beginning of the string of Roman numerals. It is important when you talk about enumerating everything, not even pseudocode. It's all about the process of breaking it down, especially verbally. Yes, exactly, right? By the time you get done, this is another good point of it. By the time you get done solving the problem, the person listening should believe that it will work. Another critical point. Yeah. And so that's what we're doing. We're just getting to that point. All right, now, anytime you want to get into enumeration of things, you always need to explicitly state the order of enumeration, if it matters, right? You can say things like, oh, I have to look through all of the input one by one, so it doesn't really matter what order I look at it in. In that case, anything will do, any sort of iteration will do. If it's important that you look through it in a specific order, you need to very explicitly state that order. For a Roman numeral, I think it doesn't really matter whether you go forwards or backwards, as long as you account for it. But we're just going to explicitly say we're going to start on the left-hand side and we're going to go to the right-hand side, right? So I'm saying start on the left, go to the right. What I want to do first is determine whether or not there are two characters available. If there are, I want to take those two characters next to each other from my starting place. I want to look it up in the symbol table. If it exists in the symbol table, then I will immediately take that value, add it into my result, and then I will increment my location by 2. If that 2-character symbol is not in there, I will take 1 character, and then I will see if that character is in the lookup table. If it is, I will take the value, I will add it into my result. If it's not in there, then I know that we have now found some symbol that is not in our lookup table at all. We have an invalid input, we can throw an error, right? That's what I want to do, because unless you tell me explicitly that you're only going to give me valid input, there's no reason there couldn't be an ampersand sign in there and all of a sudden we don't have a Roman numeral anymore, right? So that's an invalid case. Probably want to handle that. Once we get to the end, then we basically just return whatever is in the accumulator, and that's the whole solution. All right. Notice I didn't say anything about loops. Notice I didn't say anything about the actual data structure that needs to be in the result. Notice I didn't say anything about anything, really. All I did was describe a solution to the problem. You can implement that solution in any language you're familiar with, and that's the key point, right? Solving a problem is not tied to a specific implementation, all right? A lot of people have a tendency to do what I call thinking in code. Thinking in code is like, I know these structures, these data structures, I know this way of doing things, and this is limiting my ability to solve this problem, right? That is the opposite of what you want. That is the absolute wrong way to go about solving problems. Instead, what you want to do is just solve it like a human would. All right, let's take a look at a second problem for exactly the same reason. Let's find leetcode.com. Here's another problem. Again, we're sticking to LeetCode because this is the one that somebody sent me literally earlier today. All right, in this problem, you are given a string containing parentheses, brackets, or like squiggly brackets or square brackets. And what you need to do is determine if it's an input, if the input string is valid. An input string is valid if the open brackets must be closed by the same type of brackets, and open brackets must be closed in the correct order. Here is an example of true. Here's an example of false, and then here's my favorite example of false, where you have the correct number of matching brackets in the correct order, but they're not nested properly. Okay? So what I want to do is I want to solve this. You can think about how you want to solve this, and then you want to implement it, and again, solve it as a human. The way that I would do this is I would say, take whatever you're given and put it into a first in, last out queue, right? The concept here is, yes, I must know about a first in, last out queue, but that's just one of those things. Like sometimes you, in order to solve a problem, you need to have some information about, a structure. How that structure is implemented in some particular language doesn't really matter. It's going to make your problem solving a lot easier if you are familiar with these sorts of things. So what I do is I take it and I stick it into a first in, last out queue. If I see an open parenthesis, then I insert that in there. If I see another open value, I keep inserting things into this first in, last out queue. Anytime I see a close, I look at the thing that is first in the queue. If it's the correct symbol, then I remove it, right? If I get to the point where I have a closing bracket and the next symbol at the top of my queue is not the correct opening bracket, then we know we have an invalid input. Additionally, we know we have an invalid input if we get to a closing bracket and the queue is empty, also invalid. If we get to the end of the input and there are any opening brackets, any opening whatevers inside the queue, then we know we also have invalid input. And that's it. That's solving the problem, right? I've described the conditions that we need to check for and the steps that we need to take in the order that we need to go through this list. I did not actually talk about implementing the code. I didn't talk about how a first in, last out queue is actually implemented, anything like that. This is entirely about just coming up with a solution, right? And the solution is very high level, very conceptual. Somebody else should be able to look at it, should be able to understand it. Hope all of that makes sense. Okay, so that's problem solving in a nutshell. I really can't strive enough to tell you, like, as a newer developer, just solve it like a human would. Do not worry about trying to solve it in any special or magical way. Just solve it like a human would. Period. End of discussion. Right? No, you're not going to come up with the optimal solution in terms of big O notation. Like, you're not going to. That's not your job. It's not your job on the first try, right? Especially as a newer developer. Okay, you mentioned queue, but it could be any structure. A queue, a stack array. Correct. In this case, I would use a stack. Almost certainly. The fact that I mention it as a queue is there's a first in, last out queue, right? Which describes exactly a stack. There's lots of ways to implement a queue. You can have priority queues. You can just have an array exactly like you said exactly. And it doesn't matter which one of these things you end up choosing. It just matters that conceptually the question is answered correctly by choosing the correct kind of queue. You know, how that's implemented, totally up to you. Just entirely up to you. You know, there's lots of queues that are priority queues as well. You can have like a stack, not a stack, I'm sorry. You can have a heap. You can have any of the different 90 kinds of heaps that there are out there. There's just lots and lots and lots of ways to them. There's sorted sets, there's sorted lists. I mean, there's just lots of ways that you can have a queue for these things. It doesn't really matter which one you choose as long as the one that you choose conceptually solves the problem. Thanks for pointing that out, though. That was a good call. All right. This right here is another thing that I want to do is highlight that this is called finding an approach, right? Actually, I want to get into this. There's the difference between levels of solving a problem. Okay, there is first an approach, then there is a technique, and then there is code. When you have an approach is a very high level thing, right? Like, I want to sort this list and then I want to look for the things, you know, I want to use the fact that it's sorted to find some item in this list, right? That's an approach. The technique that you choose is the specific algorithm and data structures that you end up choosing, right? The fact that you choose a stack to implement a first in, first out queue, that's a technique, right? And these two things are different because a stack might not always be the most optimal way of doing things. And even a stack, you have multiple ways of implementing a stack. You can implement a stack as like a linked list. You can implement a stack as an array. You can implement a stack as a bunch of different kinds of data structures. And which one ends up being optimal for the problem that you're currently working with is entirely based on the problem at hand. So a technique is now the exact the exact choice of data structures and why you chose those data structures. This comes up all the time in like machine learning, right? We need to have. I should even add one more level to this, which is a problem. Right? The problem. I need to show relevant job ads to users on my website. Right? The approach is I'm going to score all of the job ads in terms of likelihood to click, and then I'm going to select randomly based on those likelihoods to click. Right? The technique is the model that I choose. I chose a random forest, or I chose a linear regression, or I chose an SVM, whatever it is. The approach is the same. I'm predicting a probability that this person will click on this ad. And to break it down into something that's a little easier, let's talk about sorting. Right? The problem of sorting things. That is like, I need to order them based on some value. Okay? There's lots of different approaches to this. The approaches could be like, I want to compare things that are side by side. Okay, that's an approach. Until eventually I sort them all into the areas that they need to be in. And what that means is, I'm making local comparisons in my array, in my linked list, in my whatever. It doesn't really matter. The approach is local comparisons. However, it turns out that, and there's lots of techniques for this. These techniques are bubble sort, insertion sort, selection sort, lots of different techniques that you can use for that same exact approach. That approach is limited in how efficient it can be, right? Comparing things that are close together means that no matter what, you will always have a big O of n squared runtime when it comes to sorting. And that can be proven, and you can go look up the proof for all of that. Right? So then you need to change your approach. If you want to change your runtime, if you want to change your like overall ability to solve this problem, it is the same exact problem. Nothing has changed about it. We want to order things from the lowest value to the highest value, but the approach is now different. The approach is, I want to swap things that are far away, right? Because one swap can now undo a lot of mistakes because I'm moving a lot of them all at once, whereas a local swap can only fix one mistake at a time. And now you have different techniques again. You have merge sort, you have quick sort, lots of different techniques here that all do the same conceptual idea. Things are far away, we want to swap these things that are far away, right? But then you run into the same issue. Now you cannot do better than big O of n log n. And again, that can be proven. You go look that up. Everything's cool. Right? So you need to come up with something better if you want to sort even faster than that, right? And if you have a really, really, really large data set, you have to come up with some really interesting stuff. There is a competition for sorting a petabyte of data. Now, first off, to just have a computer that can have a petabyte of data in memory is insane, just completely bananas. And now you have to think about like other things about like getting the data from this machine to the machine that actually it needs to be on for the final result set, right? Just lots and lots of crazy problems that you have to account for when you change your approach or when you change the problem. So you want to get faster than big O of n log n. You can no longer just swap things that are far away. You have to basically put things in the correct spot on one try. Right? So now we have things like counting sort and radix sort. And these sorts of things are limited to, they run in big O of like linear time. But the issue is that you have to know something about the data in order to be able to apply those techniques, and in order to be able to use that approach at all, and then choose one of the techniques, right? And again, none of this has anything to do with code. We're still talking about the problem, how it leads to an approach, how you can have multiple approaches to the same problem, and then you can have multiple techniques to each approach, right? And that's what I want you to focus on. Right now, we're focused on coming up with an approach. The actual techniques has nothing to do with problem-solving skills. Just absolutely nothing to do with it whatsoever. It's entirely about an approach. When you think about things, when your problems get more and more difficult, the figuring out the correct approach will lead you to will lead you to better solutions a whole lot faster than trying to think about what specific tools you can use to implement them. Okay. I know that was kind of a lot to throw out like in a very short amount of time. We're only 30 minutes in here, and I've only been talking for about 25 minutes. So if I need to slow down, by all means, let me know. But I feel like so far hitting sort of the nail on the head with some of these things. All right, so that's problem solving skills, and this is, in fact, let's move this up because that is something we want to talk about first. And then under here, we have this, and now we can correctly identify this. Now we can correctly identify this as this is finding an approach, right? Okay, so now that we have found an approach, now we need to move on to the actual implementation, right? This is your technique. Let me put this up here. Technique. Okay. This is the technique part. All right, great. So you now have an approach. Okay. We have decided that we are going to do a first in, first out queue, and we're going to be able to implement this, right? What kind of first in, first out queues are there that are available? In my language of choice, you're not always going to have the same option that you have in other languages. I happen to use C# a lot, so there is a very explicit first in, first out queue called a stack. However, I don't know if there is even a stack in JavaScript, right? Let's see. JavaScript stack. Implementation of a stack, right? You have to go and find one. You have to go and make one. Okay, so using a stack in something like JavaScript, oh, there is push and pop, shift and pop. Okay, so you can create one, but you still have to know how to use this in your language of choice, right? You push something onto a stack, you pop something off of a stack. This right here is an implementation of a first in, last out. This is an implementation of a first in, first out, right? And this is the difference. You have to know these things about your language, right? That's sort of the key point here. How much do you know about your language of choice, right? So I had to go and look this up. If I had chosen to use JavaScript and needed to solve this problem, then it would not have immediately come to me that you push something onto an array, you pop something off. Having gone and looked it up, oh yeah, of course, right? Of course, it's super simple. But the problem is, like, you're in an interview setting, and sometimes you can't go look that stuff up, especially if you're in a whiteboard interview setting. And sometimes the interviewers won't allow you to Google things because of, privacy concerns around, like, just Googling the problem that they gave you and then going and basically copying and pasting code. And they don't want you to do that in an interview setting, right? This is about how much you know about the language that you have chosen to implement that you have chosen to use for the solution. In an ideal scenario, the interview allows you to write pseudocode. In that case, you can basically just write down the functions. You can just say, this is a stack. This is a whatever. And then you can do things like, stack, var s. I probably wouldn't even go that far. I'd probably just say s equals stack. And then I would say s.push thing and s.pop thing, and not actually care about the implementation details of these things. Right? So those are the two functions that you would call on a stack, and I know that about a stack no matter what language it is. The stack data structure and where it's implemented in the language, not always super clear to me unless I'm used to using it. But the fact is, I don't really use a stack all the time. It's not something that comes up in my work very regularly. I think in all of my work in the past 10 years, I've probably used the stack about 3 or 4 times total. And that includes going to school. So it's okay that you're not familiar with everything. It's one of the downfalls of the current state of interviewing, that you might be asked a question where you're just not familiar with the specific topic, and it leads you to like less refined answers, right? There's not a whole lot of interview questions out there that don't have some amount of like, you need to know something going into it in order to answer it in the best possible way. And that sucks. Like, it just kind of is what it is. You just kind of have to deal with it. You're not alone in that. You're not by yourself in that. You're not, the only person in the dark. It's just the way that interviews happen right now. And until we come up with a better way to go about that as an industry, then you just sort of have to deal with it. And don't be afraid in this case to say I would use a stack. You mentioned data structures, and that's something you need to be at least conversationally familiar with, some of the common basic data structures on what and how to use them. Yeah, more or less, right? Like, I know a stack has push and pop. I know the concept of a stack. I know that it implements a first in, last out queue, right? The actual implementation details of that in my language, I would narrow it down in C# based on the namespace, but something like JavaScript where you don't, there's just, it's either there or it's not there. Yeah, I mean, like, you either know it or you don't know it. And it's okay that you don't know it. Like, it really is okay that you don't know it. This is why you want to solve the problem first as a human. Say, I would use a stack. And then once you tell the person that you would use a stack and you just don't know how to use a stack in whatever your language is because you don't know it, like, you get a lot more leniency from your interviewer on that detail because you know how to solve the problem. Right? Converting that solution into code is as simple as Googling stack in JavaScript, and I found it in 3 seconds, right? It's like, it's not that big of a deal. If you're not allowed to do that in an interview, then what you would do is you would say to your interviewer, like, I want to use a stack for this. I'm not sure what the syntax is. And they'll either tell you just make it up, or they'll tell you you can look it up, or they'll just tell you how to do it. It's one of the technical pieces of knowledge that you need to have, though. Not language implementation details, but what's a stack? The difference between a basic stack and a queue. Yeah, more or less. I don't like the way of saying it to say that you need to have it. Instead, I like to say that it places you on a scale, right? If you know about a stack, then you can solve problems that can be solved by using a stack. But if you don't know about a stack, how hard is it going to be for you to learn that or to come up with another solution, right? So there are, yeah, there we go. Yeah. So the idea is like, there are other approaches. There are other techniques. You have the same idea of an approach. If you don't know about a stack, can you implement a first in, last out queue? You'll probably end up implementing a stack, but the concept is the same. Like, if you can do this, and then all I do is tell you later on, like, oh yeah, there's a stack. You can just, save yourself a lot of time there. Then the way that you would think about that person's problem solving skills is still quite good, right? I need to put something into a place that I can get it out a whole lot later, conceivably. And that's the problem solving. So you get good for that. You get a little bit worse for your coding skills, but you take it with a grain of salt on the coding skills. Because they can solve the problem. And once you know how to solve the problem, looking up what you need to look up or explaining your problem to somebody else becomes a lot easier. Like, if someone was completely unable to solve a problem and they couldn't explain to you what the problem is, they're not going to perform very well. But if they can solve the problem, it's much easier to get them pointed in the right direction to actually implementing it, to expanding their own coding skills. And that's the key thing. Like, if you're willing to hire somebody who's junior, again, this is geared toward people coming out of college, coming out of boot camps, and looking for their second job, people who have just not been around interviewing a lot lately. Then, like, this is sort of the thing where you want to focus on your problem solving skills. The coding skills will be much more lenient in the case that your problem solving skills are better. It's still important that you're able to make progress, right? No matter what your problem is, at some point you will run into a problem where there is not just a thing as part of the language that will solve it, and you will need to implement that. So in the case that you decide you want to use some sort of functionality, a first in, last out queue, but you don't know how to implement one, you need to sit down and do that implementation, right? You know the rules. Now you go back to the problem solving part, right? Which is, okay, I need a first in, last out queue. How can I go about doing that, right? What technique can I use for that? And so we're gonna have to make it up. And in any good interviewing chain, you're going to have to make up some real solution in at least one of your interviews. I got myself out of the context of level of experience. Yeah. I find that's like one of the hardest things as the interviewer is to not take into account your own level of expertise when you're evaluating others, right? It's more about what level of expertise is needed for this job, for this position. You know, if you're going to implement some logic, you know, for a website, like if you're just going to be a back-end developer for a website or even a front-end developer for a website, and the company is willing to hire somebody who's a little more junior and level them up, then like the expectation is not on whether or not they're better than you. The expectation is on whether or not they have the skills to learn quickly and solve problems, right? The coding stuff is stuff that comes with time. The debugging stuff is, well, we're getting to that, but that one's a lot harder. So you just sort of have to make that decision up front before you even start hiring. Like, what is the actual skill level on a skill level of here's a bunch of different problems that need to be solved and how far can you get through these problems? And it's a little bit different than like, can this person write a compiler or not, right? If you have written a compiler before, writing a compiler is an almost trivial exercise. But the first time you write one, oh my God, is it hard. You have no idea. It's like so different than anything you have ever done in your entire life, where you're just like, it barely makes sense to me. And it gets complicated. It gets really complicated the further and like more complex you want your compiler to be. But the concept of like breaking down text into an abstract syntax tree and then operating on that abstract syntax tree is a fairly trivial process. And in fact, there are tools out there where as long as you can specify the notation of your language in a particular format, it will just make a compiler for you. Like, that's how easy it is, right? Will it include all the optimizations that you want to include? No, it won't. But it'll get you off the ground. It'll get you running. It'll get you started. And you can do a lot of really powerful things with things like domain-specific languages. But again, the point is that, like, if you have never written one before, it seems like it's an incredible feat of, like, just amazingness. Once you've written two of them, you're like, oh, okay, so you wrote a compiler, great, you know? And that is like where bias gets introduced into your hiring process. If you tell each individual person, you know, be amazed, and that's what should make it so you pass, that's a really bad way to look at things. It should be, is writing a compiler an interesting thing for somebody we're trying to hire, right? Just period, at the end of that sentence. It doesn't matter who is looking at it, who is doing the interview. It's if they come to us and they're like, I wrote a compiler and I solved this problem, is that an interesting thing? Then that just needs to be a true or false thing that is fairly consistent across the people who are doing the interviews for this position. That's not always the case. Okay, coding skills. So how much of your language do you know? Another thing that comes up all the time in this is string manipulation. I don't care. In almost every single interview like process for every company I have ever interviewed for, you end up getting asked questions about string manipulation. I got asked about string manipulation when I joined Stack Overflow, right? Like you don't use these functions all the time when you're working on your normal code. Like they just sort of happen to be really good at highlighting whether or not you can solve problems with a better runtime than a worse runtime. There are lots of things like string split, very non-trivial thing to implement, because you can implement it really, really, really poorly, or you can implement it really, really, really well. So it has runtime basically O in, or it has runtime basically O in squared. And there's a lot of variation in between there. And that's why people in interview settings like asking about string manipulation. So I don't care what language it is, go learn every single string function that is in that language. Learn string split, how to use it. Languages like Java have interesting things about them where they take regexes only. You can't just put in a string and split on a string. You want to know all of that stuff about whatever language you choose for your interview. Just learn about string manipulation. You will save yourself an incredible amount of time. This is collecting substrings, looking for a string within another string, splitting a string, just all of these kinds of things. Tokenization, everything. Just go and learn that stuff. Just learn it. There's no other way around it. Just learn this stuff. And these string manipulation things are actually kind of interesting because if you learn how, and I don't mean learn how to use them, I mean learn how to implement them. Like learn how to implement string split, learn how to implement substring, learn how to implement string tokenization. All of these sorts of things, you want to learn how to implement them yourself. And not just learn how to use the functions that are built into your language, because they're going to ask you like, oh, what's the runtime of this? And if you don't understand the implementation, you're not going to know. Let's see. That's pretty much it for coding skills. It's really about like, once you have a solution, how difficult is it for you to implement the thing in your language of choice? All right, the last major skill that's being looked for in these interview situations is your debugging skill. Good interviewers and bad interviewers alike have a tendency to mix your coding skills with your debugging skills. And this is, in my opinion, a huge mistake. Debugging is about locating the source of problems. It is not about solving problems. I want to really, really, really drive this in, right? The skill is locating the source of problems. I was on a mentorship call yesterday with a good friend of mine from Andela. Andela is like you would think of it as like a coding college based out of Nigeria. And they do a really, really, really great job of getting super smart people. And I do mentorship with them about, well, I guess this is only my second time really, but we, as a company here at Stack Overflow, we do it once or twice a year where we take cohorts of people and we do like these 8-week training programs or 8-week mentorship programs where half the time we talk about like coding and technical stuff and half the time we talk about like soft skills and stuff like that. I was on a call yesterday with my mentee, and he showed me a problem that he was running into at work where he had a web endpoint that was taking like more than 30 seconds to finish, right? And people were starting to get upset because it was causing the things that consumed this to crash. And it landed on him. He had to speed this thing up. And the direction that he went to speed this up was by just trying to change things, right? And this is very, very, very typical. Like when you don't know where the problem is, you just start at the top, right? You change the thing at the top, you make a change, you see what happens, and then you make a change on the next one, right? Change, revert whatever you did up there, make a change on the next one. Then you make a change on the next one. And that's like a trial and error way of going about it. And even that is fairly good. Because most people have a tendency to literally just read the code, right? And somehow magically think that we're going to locate the source of the problem by just reading the code. I want to be really clear. There's two primary ways that you can debug things, and these are super critical to learn. Number one is walk through an example. Absolutely, unquestionably, apply some example to it. You want to make this example as small as possible, right? If you're given a large amount of input, even like 10 values in an array, just take one of the values out of the array and try it on that and see if you can, let's do this. Okay, break it down into a smaller example and work through an example. That is super, super, super critical. Okay, by working through an example, and when I say this, I mean track the value of every single variable. When you get to a line, people have a tendency to read an if statement and expect certain things to happen and immediately go to that. And when I'm watching people go through examples like this, if you're not actually tracking the variable and making sure that you're executing every single statement that you wrote down in your head or verbally, you're going to make the mistake of assuming that some conditions are true, and you're going to skip right over it. Okay, you definitely don't want to do that. It's the most frustrating thing as an interviewer when I'm watching somebody else do this, because it's like, it shows me that you're not reading your code, you're reading what's in your head, right? This is why we have, like, when you write a book, you don't edit it yourself, you give it to someone else. Because when you reread the stuff that you wrote, you can only read what you had intended to write. It's just the way the brain works. Okay, so you have it in your head that this thing is going to happen, and you make that assumption, you push it through. You need to get out of your cycle with that, and the easiest way to do that is by running through an example and literally writing down the values of all of the variables as you go. That's one way. The second way is you need to find a way to measure the thing that is broken. Okay? If you're getting incorrect output at the end of your results, then you need to find a way to print out intermediate results to make sure that each step is producing the results that you expected it to. And this might end up with a lot of like print statements in the course of your writing, of you coding. But the whole point is that you need to go into it with an expectation, and as soon as your expectation is violated, that's where the first problem is. Okay? I want to be very clear about that also. There's probably not going to be one problem. There's probably going to be a lot of problems. And so you want to just focus on finding the first problem, and then finding the first problem again, and then finding the first problem again. And you need to go into it with an expectation. Without going into this thing with an expectation, you're going to have a very difficult time identifying when it doesn't meet the expectation. So say explicitly, this is what I expect the result to be after I perform this operation, and then it either is or it isn't. And give me just 1 second here. I don't normally talk this much, and I'm like, probably should get some water. Okay. The second thing is, let's say the results are as you expect. All right, that happens too, but you're not meeting the requirements of another way. Camaro084 says, good stuff. Thank you so much, man. Just going to keep going through it. If you have any specific questions, I am totally happy. Feel free to interrupt me. Okay. The second thing is, sometimes you are working through a problem and the correct results come out, but you're failing to meet your requirements for some other thing. I was explaining the example that my mentee showed me, this thing that was taking 30 seconds. It produced the correct results, but it was taking 30 seconds, right? And people were complaining that it was causing all their stuff to time out, and so it wasn't good enough. And now what you need to do is, you can no longer have the expectation that it's going to produce the wrong results, because it is producing the correct results. Instead, what you need to do is change your metric. My metric is it's taking too much time, and you need to identify what is taking too much time. Okay? The easiest way to go about this is just time everything, right? Break it down. This step, this line of code, in my function takes this much time. This line of code takes this much time. This line of code takes this much time. And the easiest way to do that is literally just wrap it in a timer, especially if something is taking 30 seconds, right? If it's taking 30 seconds, you wrap that one little segment in start timer, end timer, and then you print out how long it took. And then again for the next step, and again for the next step. And after you get done, you get this big long list of all the different amounts of times that each of these different lines took. And then you just start with the one that took the most. And whichever one took the most, You drill in and you say, okay, what in there took the most time? And then once you identify where the problem is, then you can start attacking the problem. And this specific example, this thing was taking like more than 30 seconds. It was taking like 60 seconds locally, which was like incredible. And so what we did was we put the timing around. I should be more specific. He was doing exactly, what we talked about, which is you change the first line and you see if your changes had any effect. And then you change the second line and you see if your changes had any effect. And you change the third line and you see if your changes had any effect. The only problem was there was a much easier way to go about finding the thing that was actually slow, which was just doing the timing. So we did the timing and we found out that it was this database query. This one database query line was taking like 60 seconds. So I said, okay, get me the database query and let's go to the database. And in my head, as like a more experienced developer, I'm thinking, okay, there's only a few problems that could possibly be going wrong here. This is going to be like, all right, you either have, a slow running query, or whatever's happening once the computer gets the results is really slow. It's very, very, very difficult to break down those two things, because normally that step happens as like one function call in whatever your code is. And in this case, he was using Python with pandas, and pandas was responsible for executing the query and converting the results into a data frame. So we take the query itself, the actual string, we go to the database, we run the query in some other tool, not the code, right? I think it was, MySQL Explorer or something like that. We run the query. The entire query finishes in 371 milliseconds, right? But this thing was taking 60 seconds. Like this whole section was taking 60 seconds. And it was returning 620,000 rows. And I was like, that's just not a lot of rows. That's not a lot of data, right? It was returning like, 6 variables or something. They were all numbers. There was no strings. It was just not a lot of data. So of course it was returning really, really quickly. So I said, okay, great. Now we know the problem. The problem is not the query. It's not any of the other code in this function. It's that pandas taking the results of the query and converting it into a data frame is taking forever, right? Now we know what to go look up, right? That's debugging. That's not solving the problem. That's locating the real source of the problem. The real source of the problem was that the mapping done by pandas was extraordinarily slow when using this function. We know the query was fast. Then we took the query, we ran the query, and whatever it is in Python, there was something where you basically just say get all results, and it gives you back an array of arrays. And then the schema comes as like a second variable that you can request. So we now have the schema over here, and we have an array of arrays with all of the data over here, and that finishes in less than a second. Now all we need to do is take this schema and all of these values, convert them into a pandas data frame. And it turns out that there were faster ways to go about doing that. You could take the whole thing and serialize it to a CSV in memory as like a giant string, and then you could convert it from a CSV into a pandas data frame a whole lot faster than whatever the crap it was doing otherwise, right? And it's like these sorts of things like this, that's debugging. It's not about solving problems. It's about locating the real source of the problem. And that's it. That's the debugging skill that you need in an interview, right? You have some expectation. The expectation is not being met. How do you locate the source of the problem? How do you figure out the line of code that is not acting as you expect? Is it taking too long? Is it producing incorrect values? Whatever the thing is that you need to be looking for. And that's the debugging skill. So that's pretty much it for the explanation. Just to go over the high level stuff one more time. You start off with a problem. You're given a problem. You need to come up with an approach to it. This approach determines the kinds of techniques that you can actually apply when you write your code. And that's it. That's the path. And the 3 skills involved here are problem solving skills, coding skills, which is the selection of the technique, right? And then the actual, this thing is not doing what I expected it to. Let's fix that. That's the last part of it. And I want to go through a couple examples, and you're going to see that I am probably not going to get all of these on the first try, but we're going to do it anyway. And I'm going to show you how I go about actually practicing for this, and showing when I'm in an interview setting exactly how I would go about implementing these things. And because I've never used LeetCode before, we're just going to like choose a different problem. But before we do that, I'm going to take about 30 seconds and I'm going to go get myself some water because I am having trouble continuing to talk. So I'll be right back. Please get yourself some water, stand up, take a break, make your watch tell you that you stood up and had a good time. I'll be right back. All right, and I'm back. Got me some water now. A little jazzed up. I didn't have lunch and I had all this coffee this morning, so I'm like, okay. All right, let's go find some interviewing. Discuss here. Sure, whatever. LeetCode. I don't really want to create an account. Really just thought I'd be able to start doing them. Top interview questions. Sure, that sounds like it. Play. Okay, this is LeetCode official curated list of top classic interview questions to help you land your dream job. Our top interview questions are divided into the following series: the easy ones, the medium ones, the hard ones, to help you master data structure and algorithms and improve your coding skills. Just like any other skills, coding interview is one area where you can greatly improve with deliberate practice. Absolutely, unquestionably agree. You got to practice this stuff. Most of the classic interview questions have multiple solution approaches. For the best practice result, we strongly advise you go through the list at least a second time, or even better, a third time. By the second attempt, you may discover some new tricks or new methods. By the third time, you should find that your code appears to be more concise compared to your first attempt. I don't know, I'm less interested in this one. The conciseness of the code is not nearly as important as the expressiveness of the code, which I think is much more important. Like, you don't want to be clever. You want it to be really, really, really easy to read and understand, especially in an interview setting where you literally have to convince someone else that this thing works and they have to understand it. All right, deliberate practice does not mean looking for answers and memorizing it. Of course not. You won't get very far with that approach. The more you are able to solve a problem yourself without any reference to the answers, the more you will improve. Please log in. All right, well, give me just a second here. I guess I'm going to have to log in. Do-do-do-do-dooch. Do-do-do-do-dooch. User, oh, I can sign up with GitHub. Yeah, sign up with GitHub, sure. Oh, shoot. I am trying to sign up for this website. Yes. Authorize OJ leak code. Why is it called OJ leak code? That's interesting. Okay, wow. Here we go. I guess we just close all these and just use this. Okay, now I have some new screen. I wanted to go back to leak code. You have not verified your account. True statement. Inbox. Inbox. Leak code. Verify. Confirmed. Hey, congratulations. All right, great. Refresh. Okay. Let's go to explore. Top interview questions. All right, deliberate practice. Array. I guess you just start at the beginning. See, this is what I mean. Strings, absolutely unquestionably learn this crap. They're all over the place. The string ones, you just can't get around them. You can't avoid them. And again, it just comes down to the fact that there are so many ways to implement each of the string functions, and they have wildly different runtimes. Okay, remove duplicates from a sorted array. Sure. So you're given remove duplicates from a sorted array. Given a sorted array of nums, remove the duplicates in place, meaning don't make any new memory, such that each element appear only once and return the new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. Okay, great. So that's actually not that hard. Conceptually, the way that we're going to do this, again, we're problem solving, right? We are not actually writing code. What we're saying is we cannot create any new array to put any results into, but we're going to take advantage of the fact that this thing is ordered, meaning that if there is a duplicate, they will be right next to each other in the array. So what we're going to do is we're going to put our finger on the first location in this array. We're going to put a second finger on the first location in this array. The first finger is the one that says, this is where I'm going to put the next element. The second finger says, this is the current element that I'm looking at. Okay? Now what we're going to do is we're going to look at the immediately preceding one to where we currently are, and if it is the same value, we're going to just skip it, and we're going to go on to the next one. And anytime we decide we're going to keep this one, we're going to put it here and then move forward, right? And then what's going to happen is the value of this at the end is going to be the number in the array, and we're going to have filled up the beginning part of this array. That's the plan. That's the approach. Okay, the actual implementation for this, like I said, is really straightforward. We're just going to do it. So we said we need two values here. Let me pull this up so that everybody can actually see it. Okay, so we need two values here. The first one is int current location and int new size equals 0 equals 0. And then at the very end, we're going to return new size. So the idea here is you want to specify the inputs very clearly, and you want to specify the expectation for the output as soon as possible, right? When you know the result that you're looking for, it's very easy to move in that direction. In fact, I want to write that down. You always want to figure out, actually we should put this in its own section, which is the actual studying part, which is first define your output data structure so you know what you are trying to reach. Okay, another really good hint to lead you in the right direction. A lot of times when people are solving problems, they will start by saying, okay, I know I need to do this step, then I know I need to do this step, but they don't know how to get to the end, right? So if a thing says, I need you to associate, each unique value in the input with the maximum value of some calculation, then you need some sort of map, right? So make yourself a dictionary, make yourself a hash, make yourself whatever it is for the language that you choose, and get ready to start populating that thing, right? That's it. Define the output first so you always know what you're working towards. And then once you get that, everything's going to get a lot easier because you can pretty much work backwards. All right, back to our code. In this case, we're just going to say while, again, whether you use a for loop, whether you use a while loop, a do loop, it doesn't matter. That's an implementation detail, right? That is you converting to code. This has nothing to do with the approach. I decided here to use a while because I'm not going to increment with a for, which is basically a while. So instead I'm going to say while current location is less than nums.length. And then what I'm going to do is say if current location equals 0, meaning we're at the very first element. This is an edge case where you can't look backwards. So we know we need to add this one. If it is that, or, I got a cough again. Or nums of current location equal nums of current location minus 1. And again, all we're doing is checking to see that they're the same or we're in the first one. Then what I need to do is say new size plus plus. Actually, I need to say nums of new size equal nums of current, and this needs to be not equals. Oh man, that's so crazy. Not equals. Nums of new size equals nums of current location. And then we're going to increment the new size, and then we're always going to increment the current location. Okay, I have no idea if this is going to work. All right, I'm just going to try it. And the idea of this is I just want to get to the point of running this code as quickly as possible. Okay, and I did get the correct answer in this case. Let's submit it where it actually tries it against a bunch of other cases that we can't see, and it accepted it. All right, the fact that it worked here is like neither here nor there. Okay, it doesn't matter if it works on the first try or doesn't work on the first try. When it does work on the first try, you get no chance to show them your debugging skills, right? When it doesn't work on the first try, you do get the chance to show them your debugging skills. And also, it makes you just a little bit faster. Like, instead of stopping and then rereading through it, I want to see that it invalidates my expectations as quickly as possible. Okay, I don't want to go, let me think about this and ensure that it is absolutely correct. The only reason I would do that is if I can't run it, right? If there's no test cases. If there is test cases, make use of them as quickly as possible. Get in there and press the button and just have it run. Okay, we solved this problem with me doing an explanation and going around and doing other things in about 5 minutes. Okay, shouldn't take much more time than that. Let's go to the next one. And again, if it's slower for you on the first few tries, that is totally fine, right? Focus on the problem solving part and don't worry about how long the code takes. All that matters initially is that you can come up with a solution, a working solution. Okay? Whether or not it actually works when you implement it is really neither here nor there. You just debug it and you work through your process and everything's fine. But the fact that you either can or cannot come up with a solution that will work is like the most important thing. All right. Say you have an array for which the ith element is the price of a given stock on day I. Design an algorithm to find the maximum profit. Say you have an array for which the ith element is the price given of a given stock on day I. Design an algorithm to find the max profit. You may complete as many transactions as you like. Buy and sell one share of stock multiple times. You may not engage in multiple transactions at the same time. You must sell the stock before you buy again. So in this case, your input is 7, 1, 5, 3, 6, 4. The output should be 7. The explanation, you buy on day 2 and you sell on day 3. So you have a profit of 4. Then you buy on day 4, which is this one, and you sell on day 5. So you add 3 plus 5. Okay, well this pretty much just tells you exactly how to solve it, which is you start iterating from the left. Whenever you see a drop in price between this and its neighbor, you would try to sell on the first day, and you would not buy again unless the next day is going to be higher. So we would attempt to sell on this day, but we have 0, so we sell 0. On this day, we would attempt to buy because the next one goes up. On this day, we would attempt to sell because the next one goes down. On this day, we would attempt to buy because the price goes up. On this day, we would attempt to sell because the price goes down. And it appears that we can only buy 1 share at a time. Buy 1 share, sell 1 share. Wait, design, oh, okay, hold on. So we want to keep buying here, I think. Buy on day 1, sell on day 5. Oh, interesting. Okay, so you can own a maximum of 1 share of stock at any given time, although this doesn't really explain that well. All right. Let's give it a shot. So again, our output needs to be the total profit. Return total profit. And then we're going to go from left to right. In this case, we are going to look from the 0. From int I equals 0, I less than prices dot length I plus plus. All right, so for this case, what we're going to do is say something along the lines of, if prices of I plus 1 is greater than, we also need to track how many shares we own. All right, if the prices change, prices of I, then we want to attempt to buy. Else, and then we're going to do the exact opposite of this. If prices of I plus 1 is less than prices of I, then attempt to sell. Now we have 2 issues here. The first one is that we're going all the way to the end of this array and we're looking forward, so this is going to give us an index out of bounds. This is coding. This is not problem solving, this is coding. And so we want to account for that. So really what we want to do is we're never really going to do anything on the last day. Or are we? We are going to do something on the last day. So we're going to pretend that in the last cell, the next value is always hugely, hugely negative, like infinitely negative, right? So we're basically going to consider this to be a little bit larger. So the first thing we want to do is say, if I equal prices dot length minus 1, then in this case, sell anything we have left to extract the profit. Okay? So we have now taken care of the out of bounds array, and this needs to be an else. And then at the end here, if they're equal, we don't really care. We're not going to try to do anything. Else, don't care. Just like that. Okay. So in this case, let's see if we have anything left. If owned shares is greater than 0, then we probably want to sell our shares. And we also need to track the amount that we purchased at. Right? That's how we're going to determine the end. Int last purchase price. All right. In this case, what we're going to do is calculate the profit. Total profit equals sell anything left. Is this true? Would we always sell anything left? Yes. Total profit equals last purchase price minus prices of I. And I believe that's all you have to do. Okay. So now we can say if owned shares equals 0, unless you had some threshold for min profit to trigger the sale. Yeah, but we don't in this case because the description says that all we're trying to do is maximize profit given this input. So if we have anything left at the end, then we definitely want to sell it off and like walk away with whatever we can get. All right, attempt to buy. In order to buy, what do you need to do? You need to buy on day 1, price 1. We could change the way that we do this, and instead of nope, we're just going to keep a path. Okay, so if you have no shares, then we can try to buy. We're going to say owned shares equals 1, and then we're going to say last purchase price equals whatever this value is. What is this value? Equals prices of I. And then in this case, we're going to attempt to sell. If owned shares is greater than 0, then sort of the same thing here. Like this. And again, I think this is close enough. So I'm just going to run it. I have absolutely no idea if this is going to work. Your answer is -3. Okay, which is absolutely wrong. So what we want to do is we want to debug where the issue is, right? So now we take this example. We have a really small example, which is what is the example? 7153. Okay? So the total profit is 0. The owned shares is 0. The last purchase price is 0. I equals 0. This is not true because it is not at the end of the array. We find out that prices of I minus 1 is less than. So we're in this bucket. We attempt to sell. Our own shares is 0. So our total profit, we just skip this. We don't do anything. We go to the next one. We have 1. So I equals 1. Prices.length minus 1 is not true. So we go to the next one. Prices of I plus 1 is 5 is greater than 1, which is true. Our own shares is 0, so we attempt to buy. We say own shares equals 1. Oh, and here's our problem. We didn't set the owned shares equals 0. Right? So the concept here is you gotta maintain each of your variables as you go through it. So we screwed up and we didn't set our own shares to 0 after we sold. So let's try this one more time. And again, notice that I'm not even finishing my example at this point. Like once we've identified the first problem, we fix it and we make a change. We still get a -3. So in this case, we're going to keep looking. All right. So we're at the 1. We have found that prices of I plus 1 is greater than this. Our own shares is 0. So we set our own shares to 1. Our last purchase price becomes a 1. Right? Prices of I is 1. So we set it equal to 1. Then we get through this loop. We go to the next one. I equals 2. This is false because I equals prices.length minus 1 is not the end of the array. Then we see that we have prices of I plus 1, which is 3, is greater than prices of I, which is 5. That is not true. We have prices of I plus 1 is less than prices of I. That's true. So we have owned shares greater than 0. Owned shares is 1. Total profit equals the last purchase price minus this. And that's our problem again. See, what we did is it's the new price minus the buy price. It's the sell price minus the buy price is what it should be here. And so we run it one more time. Okay, again, we got a 3. We should have gotten a 7. Okay, at this point, we still have a lot of problems, and we're going to keep going. So we're now at this point, and we notice that we have a 5 minus a 1, and the 5 minus the 1 is 4. So our total profit should be 4. Our own shares is set to 0. We come up here, we set I to 3. When we set I to 3, we then say, is it the end of the array? The answer is no. We say, is prices of I plus 1 greater than prices of I? That is 6 greater than 3? The answer is true. Oh, we didn't do a plus equals. We just set it equal to the end. And there we go. Right? Now when we run this, it won't overwrite the 4 with the 3. It will add the 4 to the 3, and we get the correct answer. Right? That right there is still a totally valid way to go about it. Like this is how code gets written, and it's okay for it to go like that. Like I just want to be really clear with that. The problem solving skills, totally there. The coding skills, a little bit less. And the debugging skills, still really good. right? Overall, that's a really good interview, especially for a good interview question, I should say. And we still got that done with all of the talking, with all of the everything in about 15 minutes, with all of the mistakes. And I got to highlight all of my skills, all three of them. I did a little bit less of a job with the coding one, but the fact that we were able to consistently identify more than one problem, like three problems, and work through them is highlighting the how good you are at debugging, right? That debugging skill turns out to be one of the most valuable skills. Really narrowing down the location of the problem and fixing each one, understanding that there's probably more than one problem, and not just saying, like, not having this expectation that, oh man, I keep running into problems, like I'm so bad at this. Like, to be able to continuously grind through and understand that it's just a process. You're going to make a lot of mistakes in the course of implementing basically everything. Like, just handle it. Just deal with it. And that's it. Read code and have a good internal compiler is so valuable. That is another good point. Yeah, like there is a fairly large amount of state to maintain in my head in this case. And I did actually kind of a bad job stylistically with this code, right? Another way to go about this would be to like decrease the nesting by getting rid of these, rid of this stuff like this, and just saying, you know, if this is less than or equal to, then break. That sort of a thing. Or not break, but continue. And then this lets you do things like bring it down to home. And it's a little bit easier. I know it sounds crazy, but just that like one little reduction in nesting can actually make this whole problem a lot easier to parse and walk through. Also, I'd suggest asking for pen and paper to track values and state. Absolutely. If you can't do it in your head, write it down. That's a really good point, Hugo. If you can't keep multiple values in your head accurately and maintain state through making changes to your code, definitely just write it down. Like there's nothing stopping you. And in fact, here at my desk, in addition to my giant, oh well, that's hilarious. That's kind of cool, actually. It's not green. It's yellow, and for some reason it's really picking up the green screen. But this is my rubber ducky that I talk to whenever I have problems. And then this is the literal stack of paper that I use to debug problems all the time. Stealth Ducky. Oh man, Stealth Ducky. That's going to be my emote. That's it. I just figured it out. It's going to be Stealth Ducky. That's awesome. Yeah, you got to... God, that's great. I'm going to put your name on that. That's awesome. Stealth Ducky. Look, you can kind of see that it's yellow around the edges. If I can get the light just right. Hilarious. It almost looks metallic. It's kind of cool. But yeah, I'm not joking. That's a really good idea. I have a legitimate like huge stack of printer paper here and about a half dozen pens sitting on my desk so that anytime one dies, I just pull out another one. And like, that's it. That's how you solve problems. You write things down. So that's where we're going. And that's kind of it. That's really all I wanted to cover. This is more of like a mentorship, show you that like mistakes happen. I have 12 years of experience in the industry, and like I wrote 3 problems in this one really simple function. What matters though is being able to solve that, being able to identify them, being able to move back out of them. Wait, is this not a body paint stream? Oh, that was earlier. Sorry, Michael Jolly. Sorry, buddy. But we can work on that again later if you want to do that. We can have a competition, a body paint competition. No, we can't actually. No, I'm sorry. I'm not going to participate in that. That's not a real t-shirt. No, this is a real t-shirt, maybe. It's just, my skin actually does this. But yeah, that's it. If anybody has questions, I'm totally happy to answer your questions. Anything related to this, anything related to, you know, the interviewing, getting prepared for doing better in an interview, whatever it is, I'm like so happy to help. I love this kind of stuff. I just, like, I really feel like one of the biggest issues that people run up against when they're going into an interview is that like they're going to make a mistake and everything's going to fall apart and it's going to be the end of the world and it's going to be so hard. It's just really not. All you have to do is just get used to like solving the problems and working through your process and doing it in front of other people. That's like the hardest thing about these kinds of interviews is like having somebody watch you. It just kind of is. You if you get it into your head that they see you make the mistakes and like that's the problem, that's just not it. What they're looking for is how easily you recover. What's your process? Can you identify the real source of the problems with some efficiency, et cetera, et cetera? And make sure you understand the problem before solving it. Absolutely, you should say out loud an explanation of how you are going to approach this problem. Then as you're going through the code, it's okay to start making choices about like, I need this variable, I need this variable, I need to use this data structure. That is the code part of it. You don't need to work through that stuff when you're solving the problem. You need to have a very high level approach first. All right, I feel like this is Jess Sariand. I feel like knowing how to work through mistakes is key. It's not like a violin audition. Yeah, exactly, right? We get to make mistakes because we get to fix them before we push them to prod. And hopefully there's tests for them as well so that even if we were to make a mistake and not find it, something else would find it. But that's it. You know, this is about the level of commenting that I would go through in an interview setting as well. When it comes to actual code commenting, that's a little bit different. That's got a lot more to do with like, you know, what's acceptable at your company. But for an interview, this is like I'm writing down the very high level like conditions, right? This is my first level of conditions. These are the things that I break on that make me choose what to do. Then I just write down the thing that I need to actually handle within there. And also, I want to point out that like we have two of these things that are exactly the same. Do not try to like merge these. Don't think about that, right? Treat them as separate cases. It's so much easier to treat them as separate cases. Just do that. Just treat them as separate cases. Don't like try to get all optimal and like put this in here as like the first one here, because then it's like, does this need to be the first if statement and then we need to reorganize these? Like, don't worry about that. Break it out into each possible individual case, right? The first one is, where am I in the array? If we don't care where we are in the array, then we're looking at whether or not how these two values compare. And notice that I also have an else in here, right? This else in here is just for my sake to know that like I considered the case of what do I do when they're equal and explicitly said I don't care. This will get optimized away by the compiler. Like this isn't even going to cause any kind of code issues or anything like that. Definitely do not try to optimize when you're just trying to solve the problem. Optimization is something that happens later, absolutely. Yeah, making it work and making it explainable. Exactly right. In some cases, performance will matter, but they will almost certainly tell you that up front. Like, other than that, working solutions and solving more problems than the person before you or the person who comes after you in the interview process, that is much more important. Like get as deep into the questions as you possibly can by just solving them as easily as you can, right? You know, if it turns out, you know, this is a great example of like the discussion I had earlier about, you know, the guy who the code is correct, right? It was putting out the correct answers. It was giving the correct values as results. The problem was it was taking way too long. Like that's a second problem. You solve that later. The requirements have changed, right? Making sure the values are correct, that's the first thing. The second thing is making it fast. And all of that, if they want you to make it fast in an interview, then you make it fast or you don't. You don't need to worry about that though. You need to worry about having a working solution first and foremost. And that's it. All right. Now, need to figure out how to package all of this up, write a blog post, and get this to the people that I care about. You know, people who are graduating boot camps and whatnot. Not 100% sure how to do that. Maybe I'll just post it on social media. Maybe I should actually find out when the cohorts are ending. So the summer semester is almost done. People are going to start doing their interviewing right at the beginning of the fall. Make sure you add links to the examples test. I don't know what you mean by that exactly. You mean these examples right here? Like this URL? Oh, like leak code, yeah. Okay. Absolutely. Right. Yeah, this is the thing. When you get in there and you start doing like your work, you run into problems like this all the time. It just happens. It's just part of being a developer. It's just get used to it and make it fun. You know, make figuring out what that little problem is not overwhelm you with grief. Make it, excite you that you figured out the next problem, and then the next problem, and then the next problem. Because they just happened. Like, that was legit. I have never answered this question before. I wrote 3 bugs in my first try. Like, it just happens. Just be cool with it, right? It's just part of life. And if you want to see me make a whole lot more mistakes, you can go and watch some of my previous videos on demand at my website, where I make tons and tons and tons of coding mistakes. But yeah. Speaking of coding mistakes, let's talk about the coding mistake I uncovered today. So we've been building this model for these decision trees and making this random forest stuff, and we finally got it to production. Hooray! Today, when we got it to production, actually it was before we got it to production that we found the error, but we released it to production anyway to crash test it. The concern is, we did this thing, we got it to be fast enough, everyone's super excited. The only problem was, every time you were shown job ads, you were shown job ads for what appeared to be jobs basically halfway around the world. Doesn't matter where you were. If you were in like New York, you saw jobs in like Singapore and Hong Kong. If you were on the West Coast, you saw jobs over in Australia. It was really, really like, what is going on here? I mean, it was just crazy. It was just completely bananas, right? So we went through and we started looking at the code, and we were like, we have done the value test. Like, we've got all of our unit tests in here. We know that the correctness is there. Like, what in the hell is going on? And so what we did after that, we said, okay, let's take one step back. Let's see if there was, some sort of bug, in the code that we implemented on the website side. Maybe we need like a 1- or something like that. Like, maybe I just missed something. And no, all of that was correct. And so we took even one step further back than that. And we said, what about the data that we trained it on? Was the data that we trained it on correct? Well, sure as hell it was not. It turns out that there was a bug in how we calculated the distance, so that for all of the people who clicked, it just said they were halfway around the world. Literally 12,250 miles or something like that. And so it became, to this model, really obvious that if you're exactly halfway around the world, that's the only chance you have at clicking on a job. So no matter where you are in the world, it's like, that's all that matters. Just get as far away as possible. So now we have to go retrain the model once we fix that bug. But to keep, to let you know, like, new job, how do you, yeah, exactly, right? Or what new hypersonic jet are they making? Oh man, if they had like a little space thing where like you got in like a rocket and then it took you halfway around the world, right? But you got to like visit space. I think people would actually move halfway around the world a good bit more often. I want a new job so far from here. Yeah, that's what it was spitting out. But it's a super interesting thing to find. But the funny thing is, like, that mistake was made 6 months ago. That was made in October. Well, 8 months ago. That mistake was made in October of last year, the very end of October. No one noticed it. We had 3 different people train models. We had, 2 different people work on the implementation. The data scientist didn't catch it. Like, it's just one of those things where it's like, bugs like that slip through. They're hard to track down, and figuring out the real source of the error, like, that's just the debugging step. It happens. That's it. Yeah. It was quite frustrating, though. It turned out, though, that it was, like, really relieving, right? Because it was like, oh, man, it's like we did all this work. We just spent all this time, a lot of developer time, a lot of data scientist time coming up with this model, implementing it, spending the time to make it fast, dealing with the architecture team to like get the last few hurdles out of the way, building the deploy, getting the code reviews done for all of the shit to get it in there. And then it was like literally 30 minutes before we were going to do this crash test and like make sure that all the technical bits were working. It was like, it's just returning complete crap. I mean, just complete crap. And so we got in, we did this analysis, and we noticed that like only a very small subset of the jobs were getting high scores for any given person, and the rest of them were like, it will never show this job. It will just never do that. And we're like, that's got to be an issue. That has to be a problem. And we fired it up locally, made a copy of some of the jobs from production, and it started showing us jobs halfway around the world. And if somebody hadn't like pinpointed that all of these jobs just happen to be halfway around the world, it would have been hard to figure it out because there's 800 features you got to go look at. How are you going to know which one of those 800 features is the one feature that we calculated wrong? We made a sign for our house a few years ago. Our family motto, El Factum Errata, looks all legit and fancy, translates to mistakes will be made. That's awesome. I'm going to design a family crest around it. That is awesome. That is super awesome. Yeah, mistakes will be made. Yeah. Do you have kids by chance? I have kids. My 2 kids. One of them is like super creative and does everything, and the other one just like watches TV. Oh, 2 boys. Whew, feel for you. It's my boy that's super creative, but like he does insane shit, like going outside and finding the like paint that we used to paint the walls in the house when we moved in, and he decided to paint the brick on the outside of the house because he learned how to spell his name, and he wanted to spell his name out of whatever materials he could get his hands on. Yeah, that was a fun day. I think that was the most upset I have literally ever been in my life. Where I was just like, it wasn't small. It was like the whole freaking side of the house because it's paint. He did this. He got the paint bucket off of a shelf that was out of his reach. He somehow managed to open the paint bucket. And then he's 5, and he was 5 when he did this. And he got a paintbrush, and he painted his whole freaking name. He did all of that in about 3 minutes. 3 minutes. That's all it took. Yeah, I have a 3-year-old and a 5-year-old. It could be worse. I know it could be worse. I'm happy that he is super creative and all of that, but like the amount of money that I have put into cleaning the house, it was like go buy a pressure washer because that's the only way you're gonna get this brick clean. when you and then like God, just 2 weeks ago. Oh, I did. I have a picture. I don't know if I have the picture. I have a picture somewhere. I think I tweeted it actually. And then just like 2 weeks ago, he went out on the deck, got himself a Sharpie. Don't ask me where he got a Sharpie because I have no idea where we even have Sharpies. He just found a Sharpie. He goes out on the deck. We have this like wooden deck. And he just starts writing cryptic messages because he doesn't know how to spell. So he just starts writing cryptic messages from literally one end of this deck to the other. It's like 40 feet long, and it's just like one giant freaking message all the way down. It was really unbelievable. I was kind of frustrated about it. And I'm like, good thing I own a pressure washer. Because that's what it took to get it off. Let me catch up here. We made a sign. Yeah. Named Didn't Do It. And the other is named Not My Fault. Yeah, that is. Oh my gosh, yeah, my son didn't do it. No, Helen did it. And she's like, no, I didn't. I was watching TV. That's what we hear from her quite a bit. One of mine got into zombie and survival stuff. Took mud and smudged Raiders Beware and Send Help on the back of our garage. Oh, jeez. At least it's mud. Well, no, it's still bad. It's still bad. Yeah. It depends what's on the wall. Send help. Yeah, tally up when he turns 18. Didn't notice it for 2 weeks. I couldn't have missed mine because as soon as I pulled out of the driveway, it was the whole back side of the house. it was it was a thing. It was a thing. Like I said, that was the absolute maddest I have ever been in my life. And like ever since then, I've kind of chilled out quite a bit because I was like, my body can't handle being that mad. I'm just getting way too old to be that mad. All right. Okay. Speaking of my son, I have to take him over to his like ninja class, his like gym class. So I think I'm gonna wrap this up. But let's go ahead and find somebody to raid. Let's go ahead and find somebody to raid. If you have suggestions, please let me know. I'm open to anybody. It doesn't have to be. Oh, that's not how you do that. It doesn't have to be somebody on the live coders team, anything like that. I do like to keep it restricted to science and technology to sort of share the love here. How about Lizzie Live? I think it's going to be Lizzie. All right, pick a channel to raid. Lizzie. All right, if you're not familiar with Lizzie Live, she is one of the members of the Live Coders Twitch stream team. You can find a link to that right underneath the video here. It says Live Coders. We're going to go ahead and raid. And I believe they're working on a game currently using Unity, which would be super interesting. A lot of fun hanging out in the chat over there as well. So when you get in there, just drop a line, say hi, and let them know where you came from. I don't have any sort of icons or anything like that, but I really appreciate everybody stopping by. And I'm so happy that like we got through all of this. Hopefully you found it useful. Hopefully you found it valuable. I'm gonna have the video on demand up for this later today on YouTube. I would really like, if you don't mind, share it with anybody. Also, yeah, have a great 4th of July. I think I am actually going to go ahead and stream tomorrow and Friday. I'm not sure if it'll be at the regular time, but I'm going to go ahead and do it just because I got to get more consistent. Anyway, all right. Here we go. Just drop in, say hi when you get there. And again, thanks everybody. We'll see y'all later.
I can't afford to do that right now.